Right, hello, this is a practice run for a presentation that I'm going to give later today at the Clojure Provo meetup online. So it is about ClojureScript and Firebase. Specifically, I have recently built a little app using ClojureScript and Firebase. So I'm going to be going over its architecture and talking about some of the pros and cons in Firebase and some of the techniques I used in Clojure to build it. So I've called it Mystery Cows, and you can find it here. Oops, sorry about that. So you can find it here at cows.jacobobriant.com. And it's a version of the board game Clue, if you're familiar with that. And let me just give you a quick little demonstration. So I've logged in to 3 users on this already. So I'll just demonstrate it. The usernames here are generated automatically from a list of Shakespearean insult words, which is my favorite feature, actually. So user 1 is Puking Applejohn. So we'll create a game, and there's a little chat box here. And oops, I use the Dvorak keyboard layout, and sometimes I forget I'm not in the right layout. So there's hello, so you can say hello, and over here. Okay, so the game shows up, and we'll join. There's a cold start, I believe, which is why the first join takes a little bit. But there we go. So yeah, voila. So a game lobby. So let's start the game. And now let's see. Let me go to the other screen so you can see more of it. This works better on my large screen. So anyway, so here's the board game. And the object of Clue is you have a bunch of cards. Well, I won't bother explaining it. If you haven't played Clue, just go look it up. Pause the video, go look it up, and then you'll understand this is Clue. It's a deductive logic game. So we have some cards, and we're trying to figure out what cards other people have. So Gore-bellied miscreant is their turn. So we can roll the dice, and we can move. Let's see. I'll just move to a normal square here. And then we can do things. Okay, let's see, whose turn is it now? Cribbling Clackdish. Okay, so let's try roll the dice, and I'll try to demonstrate going into a room soon. All right, so let's see. So we're blue, and let's go into the dining room. So now we can make a suggestion of who we think committed the murder. So let's say we think it was Mr. Green with the revolver and in the dining room, since that's where we are. And we have the revolver, so we know no one is going to show us that card. So we made a suggestion, and Gore-bellied miscreant needs to show us something. So we can pick a card to show them. Let's do dining room. So now it says here, we have a log here of all the suggestions and cards that we showed. And so we showed them the dining room. And if we look over here, we can see, okay, they showed us the dining room. Great. So now we can cross that off our list. If we go to the other player, of course, it just says we showed them a card, but we don't know what it was. And that's basically it. You go around and go into different rooms and try to guess each other's cards. And I'll just demonstrate the last bit. So when you think you know who committed the murder, you can make an accusation. And let's say we think it was Mrs. Peacock with the lead pipe in the ballroom. And of course, that's wrong. It was actually mustard, billiard room, and lead pipe. So that's the game. Voila. Anyway, board games, I think, are a great thing to test out web application architecture ideas, because board games are like fairly complex. They're multi-user applications. You need to get real-time updates from the other players, and they're also not just CRUD applications. They have significant application logic that you have to implement and things. So I think board games are fairly interesting for this kind of thing. To give more info about like why did I build this. So a little background on myself. So I've been using Clojure for about 4 years and started using it full time about 1.5 years ago when I quit my job and started trying to be a startup founder. I'm still working on that. Anyway, so web dev in Clojure is great. Takes forever to learn, unfortunately. And I've learned a lot, since I started doing it full time. And so I decided to start working on, online Clojure guide. It's called the Solo Hacker's Guide to Clojure. And so I've started kind of encoding a lot of these things that I've been figuring out into that. And so this application, Mystery Cows, is a little project that I'm using as an example project to help teach these things. Just as a little caveat, of course, like different projects are in different stages, and pretty much all my work as a startup founder has been on very early stage projects, of course. So if you are working on much later stage projects doing things with like scaling and optimization, that's my experience just hasn't been in that realm, so I may not have lots of insights for you. But anyway, let's move on. So Firebase, I'll give a quick overview of Firebase for anyone who is not familiar with it. So Mr. Cow uses these 4 parts of it. And so, by the way, Firebase is basically like a mini version of AWS that has a very good developer experience. So Firebase is much more targeted at that like early stage project area. Not to say that it doesn't work for scaling applications, of course, but it's not AWS. So anyway, so these 4 let's see, I'll cover hosting and authentication just very briefly. I've been using those 2 parts of it for about a year. They're great, super easy. Authentication especially is just a total drop-in solution, enables like email, login, and third-party SSO, like with Google or Twitter or Facebook or whatever. So very nice. It just handles all that stuff for you, including like things like password reset and blah, blah, blah. So I've always used those 2 things for my projects since I started using them. Now, Firestore and Cloud Functions, I started using more recently. So Firestore, it's a database like the rest of the Firebase, so it's very easy to set up, especially if you're already using Firebase authentication. Firestore integrates with that, which is very nice. So you can, if your users are logged in with authentication, then they can write data to Firestore. And there's a rules system, so it'll use their authentication credentials so that it can authorize reads and writes, which is very convenient. So very little setup required. And then the rules system, part of the idea is that instead of having to make a REST endpoint for every little piece of data that you want to interact with in the database, you can just set up a list of rules. So for example, we can say, in the games table, if user A is a member of that game, then they have access to read and write certain parts of that game. And so we can encode those rules so that we don't have to set up a bunch of endpoints, and it's very nice, very convenient. So recommend that. Also, flexible data model. You can do normalized graph data. I was originally a little turned off to Firestore because as I understand it, the original Firebase database was basically just a big JSON document, big hierarchical thing. And I like normalized data, so I never really looked at it. And they still brand Firestore as like, oh, it's a document database and it's hierarchical and stuff, but despite that, you can store normalized data in it quite easily. It's idiomatic for that, so it's a lot better than I thought it would have been, actually. And of course, I mean, the original big value proposition of Firebase was the subscribable queries. So you can subscribe to slices of your database and then automatically get updates to your client application when it changes without having to do any extra logic there, which is very nice. And that is a big feature that I've used in Mystery Cows, which I'm excited to go over. So a few of the cons is, first of all, queries are very restrictive. It makes me laugh a little bit because you look at the Firestore documentation and they say like powerful queries, like extremely expressive, and I'm like, well, I guess if you've never ever used SQL, but anyway, basically how the queries work is that they only let you look at one entity or document at a time. So basically you can do filtering and sorting operations, but you can't do joins. So you can get a list of documents from a games table or a list of messages from the messages table, but you can't write a query that will all in one go say, find out which game I'm in, and then also get all the messages for that game. You have to do one query first to find out like what game is the current player in, and then do additional queries to get all the other things associated with that game, which actually has turned out to not be as bad as I thought it might have been, but I'll go more over that later. That's the other thing. Rule system is a little bit bug prone. I mean, it's just kind of the same thing as the feeling of like writing JavaScript versus Clojure. There's you have to watch out for like making sure, okay, is this property on this bit of data before I try to access it so I don't crash. And the annoying thing too is if something is non-existent and you try to access it, it'll crash, and then your query from the client will stop updating instead of just having a no-op, which I think would be preferable in most cases. It crashes. So I found it was a little bit frustrating writing the rules and getting them to actually work, but they're okay. Also, I think personally with spec, we can do a little bit better than what they have with rules currently. Clojure spec actually is a great fit for this kind of thing because you can use it to test, okay, the shape of the data that's coming in, is that the kind of shape of data that we want to allow? And so it works quite nice. And then, of course, if you're familiar with Datomic and Crux, there are a lot of features associated with that we just simply don't have. In practice, like for a lot of apps, it probably doesn't matter that much. For this app, it certainly didn't matter, but I've written other things where, for example, where data code locality was a critical feature. Anyway, so that's Firestore. I have also written a little wrapper library over it. You can find it here. It just makes using Firestore from Clojure a little bit more convenient. So this is an example of writing some data to Firestore. This also shows you like what the shape of the data looks like. So in Firestore, we've created a users table. They call them collections, but old habits die hard, so I'm going to call it a table. And here we're assigning a specific ID. If we wanted, we could omit this, and then Firestore would just generate a random ID for this document. But anyway, so we do that, and then we can put in, oops, sorry about that. Then we can put in a map, and it'll save it for us. We don't, Firestore is schemaless, basically. So you don't have to set up any of this beforehand. You just go ahead and write. And this is what it would look like if we were using Firestore directly. It's a little bit more imperative. And these are some examples of reading data. So both query and write are functions from this library that I've written. And so this is an example of how you could retrieve all of the documents in the users table. So this little bit here, I call it an ident. So I've kind of stolen this sort of structure from Fulcro, where they have a vector where the first thing is the table and the second thing is the ID of the document. So I do the same thing. So if you omit the ID, then the ident just means the users table and it gets everything. This is actually a shorthand for doing a map with ident set to this users thing. So if you want a more complicated query, you have to use the map form. And then you can add things like where clauses. So you can put a list of these vectors. And so here we're just selecting all the user documents that like tennis, pretty clear. And then you can use pull to get a specific document. So yeah, that's Firestore. Now the other bit, Cloud Functions. So this lets you run backend code, because nice thing about like the rule system, like I mentioned, a lot of the time you don't have to set up backend endpoints just to access the database. However, there are a lot of times where if the right authorization logic is somewhat complex, you're just not going to be able to do it in rules. So for example, In Mystery Cows, a board game, there are a lot of state transitions, so for example, when you roll the dice, we have to make sure that, one, the game is in a current state. We have to make sure that it's your turn, and then we have to generate an automatic dice roll and then stick that in the database. Um, and and there are other things too that are more complicated than that. But anyway, so when you need to, you can use Cloud Functions to just add an endpoint, and then instead of writing directly to Firestore, you just do a request to the endpoint, and then it'll write for you like a normal app. And it's serverless, so again, very easy to set up. And like Firestore, it also integrates with authentication. So, you don't have to do any extra work to like verify the user's authentication tokens. You can do that very easily. So it's all right. The downsides is it's not the JVM, especially being a Clojure developer. I think using Clojure on the JVM is a much better backend experience. You just have access to a lot more stuff. There's opportunity for better performance too, especially if you like set up WebSockets and things. I find that Cloud Functions do have a little bit of latency, which may or may not matter for you. Another little bit sad thing is that because of the way functions are set up, you don't have a long running function all the time. You just have it when you submit a request, it spins one up and then handles the request, and then maybe sticks around for a while, but not necessarily could be killed anytime. And I found that out of the box, at least, I was not able to inspect state from my editor, which is a little bit sad. But it's, I don't know, you can maybe live without it a bit. You can always just go back to print statements, which is mainly what I've done. So that's functions. In general, like hosting and authentication, I mean, they're so simple, and I find have made life a lot easier for me, especially authentication. So I would say definitely take a look at them. I plan to use them for pretty much all of the projects I work on. And Firestore and functions is a definite maybe. Especially for like early stage things, it's very convenient being able to just set them up without having to do any infrastructure setup. But they do have some limitations. So I'd say think about it. They could be handy, but maybe not. Anyway, so that's the introduction to Firebase. You should all check it out. Now let's get into the really fun part, which is the Clojure code. This is the organization of the front-end ClojureScript app. It uses what I've started calling the pentagram organization. So I've got these three parts. You'll probably be familiar with this, from most Clojure apps or any front-end app. I guess it's basically analogous to model view controller. So the cows.db namespace has a bunch of data that we save, and components has all our React components, which we render using this db as an argument, and then mutations is a list of just functions that mutate the database. In reframe, these would be events, and we'd have this event handler that would handle them. But for this, this architecture is a little bit more simple. We just swap on the atom directly. Well, no, we don't actually. We write to Firestore, and then Firestore swaps on the atom. And then these other two namespaces, util is just a namespace I put in a lot of like application logic and things that aren't tied directly to these. And then lib is a special namespace. It's like util, but lib is basically a staging ground for functions that I want to move to a separate library. So I have another GitHub repository called Trident, which has a bunch of stuff in it, and it's just everything that I abstract out of various projects I work on, I put on Trident. So lib is basically the staging ground for that. So later on, I'll take all this stuff in here and move it out into Trident. So let's look in the code. So so this is the repository, Mystery Cows. And let's just dive in a little bit. If you want, you can look at the build code a little bit. It's a little bit interesting. We're using Shadow Clojure.js, and then all the build tasks are just in this little bash script I've written, which I think is quite convenient. But anyway, so source cows. let's see, I'll show you this bit really quick. This is just the file that generates the HTML. So to bootstrap the app, we generate the HTML app, or I mean HTML file, and then here we link to the ClojureScript file that is outputted by Shadow. So let's take a look at that now. Okay, so core Clojure. So as I mentioned, this is the top level namespace, and this we use dependency injection so that these namespaces don't rely directly on each other. For this app, it doesn't really make that much of a difference, but it just made me feel a little bit better. So that's what we do. So core, so we can see we're importing mutations and components. Oh yeah, and DB. So all three of those. So the way we do dependency injection is we're creating this map called env. And so it's mapped from keywords to all the vars, well, all the functions that are in the other namespaces. So we import, dbenv, mutations env, and put it in there. And then we stick a namespace on the keywords so that they're nice and separate. So yeah, let's see. Let's take a look at components. There's not any, like if you've done ClojureScript front-end development before, there's probably nothing here too earth-shattering. It is written in Rum, so if you have not used Rum before, this could be an interesting opportunity to take a look at it. Let's see, here's an example of a component, turn controls. So this is like this component right here that lets you interact with the game. So it changes. So for example, here it includes the roll dice. Excuse me, the roll dice button. So here you can see, we have DB keys. So these are all our bits of denormalized data, and I'll go over how this stuff is created later. But so for example, we see, is it your turn or not? And what is the current state of the game? And then we have certain mutations. So when they click roll dice, we're going to call this roll function. So for example, here we just do a case on the state and say, okay, it's well, let's say start turn. So someone's going to roll the dice. So we say, if it's your turn, we show you a button. And then if you click on it, then we call the roll function. And then this env object right here, we just pass that along everywhere. So, all the components, we pass this env object down the call stack. Let me show you, so for example, here, at the top level, the game, we're passing env. And same thing with the mutations. We just pass env in. So the mutations can get access to the bits of denormalized data. And that includes the top level atom. So the mutations will get the atom that they swap on from here. And actually, I'll just show you that right now. Mutations. So here's an example of initdb. When we start out, we get the user's information from Firebase authentication and swap it into the DB atom here, which we're getting right there. Most of these mutations are fairly simple. So for example, like send message, when you send a message in the chat room, it'll use that trident.firestore library and just write the message directly to Firestore. So we're using rules to authorize this write. Now, most of the other mutations are not using Firestore directly. They're using handle, which is a cloud function that I've set up. So this is like a reframe style event. So we're saying, okay, this user is triggering a start game event, and we're sending this to our backend function. And then that function will handle doing the state transition. And we'll look at that code a little bit later. Okay, so yeah, actually there's some more interesting stuff here, but I want to get to it later after I show you the database, because this is my favorite part of the whole app. Super cool, especially the last part, which I'm very excited to show you about. Anyway, so DB, so here's our top level atom, and then everything else is derived from this atom. So there's some cursors, and then derivations. So both this def cursors and def derivations macro, or these are macros which I have written, see they're in the live namespace. And they're just a less verbose way to use RUM cursors and derivations. And if you're not familiar with a derivation, it's like a reaction in regent. And if you're not familiar with that, then it's a piece of data that is computed from the values of other data. And it is updated automatically. So whenever we change something in the database, all these things will be changed. So for example, current game. This is taking a list of game documents or hash maps really, and we're going through them and finding out which one contains the currently logged in user's UID. And whichever one, once we find a game that has it, then that's the game we're in. And if there are no games, then it'll be nil, and then we know, okay, they're not logged into a game right now. And similarly, all the rest of the stuff, we just pull stuff out of there. But now, the interesting question though is, how do we get data here in the first place? Because when we first load this app, this is going to be empty. And all this data is also going to be empty, so there'll be nothing here. But now at the very bottom, I have this piece of data called subscriptions. And the way this works is this is a set of query objects that can be passed to the trident.firestore library. So you may remember I demonstrated doing queries with that database or with that library a little bit. And so for example, what we're saying here is that so we're saying, is the current game ID available? If it's not, then it means, we're not part of a current game. So, so we're just in the lobby. And so if not, then these are going to be the queries that we want to subscribe to. So what these say is we want to get a list of games and all the games where the current state of the game is lobby, or the current state, or any games that contain our UID in the players. And this is necessary because even if you are part of a game, when you first log into the app, like say you join a game and then close the window, but then open it again, when you load the app, it's going to be empty. But then it'll use this query to see just in case you actually are in a game, and then once it does find out, oh, you are in a game, or like say you're in the lobby and then you hit join game. Well, actually, never mind. No. Even when you hit join game, this query will still get it since it's lobby. But yeah, either way, it'll get the game, and if you're in one, it'll find it, and then these derivations, like once that data is merged into the database, these derivations will update. And then, current game will update and game ID will update. And then automatically this will change because now this will be true. And then the subscriptions will change. And instead we'll say, only get the game that we're in and get all of the current players' cards, get the messages, get the events, and get some other data about like who showed you cards and stuff. And the cool thing is I have a bit of code that watches for changes on this bit of data. And so whenever this derivation changes, it will automatically subscribe to any new subscriptions. And it will unsubscribe from old subscriptions, and it will garbage collect the data from those subscriptions. So it's a totally declarative way to use Firestore queries to get all the data you need. You don't this is all you need to populate the client-side database. And so as I was mentioning a while ago, how Firestore queries are a little bit restrictive because you can't do joins. This lets you do joins declaratively, basically on the client side. So it makes it not so bad because you can just, as I mentioned with these subscriptions, you'll load the app and then it'll go through several iterations of automatically pulling one query from Firestore, going through it, and then finding a new piece of data to join on some other query. And so then it'll do the next query, and then that'll make the subscriptions update. And this is totally just automatic declarative. All you have to do is just set up these derivations and these subscriptions, and it's super nice. And excuse me. And going back to mutations, this is the code where we set that up. So initdb, again, we're going to call right when we start the app. And this maintain subscriptions function, excuse me. So we pass it subscriptions, that atom I was just showing you. And then we pass it a function, which what this function needs to do is it takes an element from this set. And then given that element, it will subscribe to that data. And it will return a channel, an async channel, with any updates to the subscription. And that's it. And maintain subscriptions is what will handle like watching for changes on here and resubscribing, unsubscribing. Now this function subscribe is up here, and it's using some other functions that will take the values from that async channel and then set them into an atom, into the DB atom for us. And this is the bit actually that handles the garbage collection, because when this function sees that a subscription is closed, it will close the channel. And so that's how we know the subscription is done. And so this function, this merge subscription results, when it sees that a channel has been closed, it will clear out all of the data from that subscription. So again, just to describe, like this function, it does not handle swapping any data actually into our app. It just handles opening and closing the channels. But then this function takes those channels, and this function is what then takes the values from the channels and puts it into our client database. Anyway, so that is basically the front end. Hope you enjoyed it. I really enjoyed working on these little functions, and you can take a look at them sometime if you like. They're just in here, maintain subscriptions and merge subscription results. Other than that, there's only one more little thing I want to show you, which is the FN. So these are all the cloud functions. Actually, there's only one at the bottom, is our handle function, which I showed you. And then I've set up a multi-method here so we can take those like reframe style events and then dispatch on the event type. So we only have actually one cloud function that we use, and then we dispatch. Now all of these, like these are all fairly simple. I'll just show you the roll dice one. So they all follow the same pattern. So UID, so this is populated automatically for us by Firebase because we're using Firebase authentication. And so what we do is, and they tell us a game ID. So what we do is we use this function, we retrieve the game that they tell us about, and then we check for something. So we make sure that so the current player of that game is in fact the user who is sending us the request, and we make sure it is the start turn state, which means they can roll the dice. And then once we check the conditions, it's authorized. So we do the roll, and then we write it to Firestore for them. That's pretty much it. So yeah, feel free to take a look at that, but nothing super exciting, I don't think. Anyway, that is the app. Hope you enjoyed it. Some future ideas. The exciting thing is, once I realized that even though Firestore queries were somewhat restrictive, like using that setup I showed you, we can still go quite far using queries like that. And the cool thing is, with Crux or Datomic, I don't think it would be that hard to set up our own queries that way. I mean, they're not going to be data log queries, but we can still join them on the client side. And using the transaction log, you could define a query as basically a predicate, like a spec predicate maybe. And so on the client side, you can say, subscribe me to all entities that satisfy, this predicate. And then, we do an initial query with data. We could do the initial query with data log. But then on any new ones, we just look at the transaction log, and any new entities coming in, we just apply the predicate, and then we say yes or no, send it to the client. And that is totally enough for this kind of setup, which I think is quite exciting. And then being able to, using Crux or Datomic, we can just have a full Clojure backend, which I think could be a lot nicer than using Firestore and functions. And then also, Materialize.io has recently released SQL subscribable queries. So I haven't played around with that, and honestly, I probably won't for a while, but if I'm working on something and I get to the point where this kind of setup with this restrictive queries is a little bit too restrictive, I think this would be a really interesting thing to look at. So that is everything. So if you liked that presentation, there's more where that came from if you subscribe to my newsletter. And see you around. Bye-bye.